Good day everyone, I am Rommuel Lalic and I will show you on how to use the Hungarian method for assignment problems in matrix. For a brief context of this video, I will show you the history of Hungarian method, on how it was created for the assignment problems, and for the next three, the steps on how to solve a minimum, maximum, and unbalanced assignment problems. Thus, for you to have an idea on how the method will be applied when encountering these types of problems. The Hungarian method was created by Harold W. Kuhn or Harold William Kuhn, who's an American mathematician primarily in the field of optimization theory and game theory. He published the Hungarian method for the assignment problem dated year 1955, where it described as an algorithm for constructing a maximum weight perfect matching in a bipartite graph, which can be represented in matrix, that I will discuss later. The contribution of the two renowned Hungarian mathematicians, Eugene Ugavary and Diznij Kunij, from their theories were Kuhn's theorem in game theory stated that for every mixed strategy, there is a behavioral strategy that has an equivalent payoff, and Kunij's theorem for graph theory. The elegant method that Kuhn's illustration had impacted works of other Hungarian mathematicians that give birth to theorems that was published and improved, like the Fold-Furkinson algorithm and such. So the first one is the minimum cost efficiency. As you can see here, this is the matrix, where it is an array of elements in rows and columns. The assignment problem in this case is where you will assign the four hard staffs in the flexible field that will guarantee the minimum cost per task assigned, independent from each other. This is where the method will be used. So as we can see here, there is four person here: Darren, Clive, Eder, and Sylvie. The rows in the matrix being the people, columns being the task, and entries being the cost. You also need to make sure the rows and columns are equal to each other as a criteria for doing the Hungarian method. First, you need to do is subtracting the minimum value of entries in each respective rows. As you can see here, the minimum value of the respective rows is 100, 120, 90, and 140. Next, we'll be subtracting the minimum value of each entries in each respective columns. For here, the minimum value for each task in their respective columns is 0, 10, 30, and 0. We will now check the optimization of the problem. This is where you will draw lines covering all zeros of the matrix. First will be row scanning. Row scanning is where an exactly 1 0 in the respective rows is needed to mark a line. The line will be vertical to that of the 0. Next will be column scanning. Column scanning is opposite to that of a row scan, which crosses out 0 cells and marking a line horizontally to that of a 1-0 column. The minimum number of lines should be equal to the number of x and y's, which are the people or tasks. It will confirm the solution for the problem. If the number isn't met and the optimal allocation is not found, you need to subtract the smallest number between the cells that are not marked, which is number 10 here in this table. The number 10 are also added into the intersected number lines. Meeting the solution, we will now start the final allocation to what the corresponding zeros to find the most efficient cost. In this case, we started at the top, where Darren has an exactly 1 0. Corresponding to that, you will remove the task and Darren to find the other efficient and optimal solution to the tasks. Finding the minimum cost will gradually save your expenses. As we check the other possible costs, it is evident that we found the most optimal way of paying the staffs. Next will be maximization, where we will solve a problem for getting the most efficient production value that can be achieved by the operators. So, as for maximization, you will first transform the problem into the minimization which I showed you earlier. To do that, you need to subtract the largest number of the entries to each of the inside the table. After that, you will now follow the steps in minimization, where you will subtract the smallest number each row in its respective rows, as well for the columns. After that, checking the optimal allocation, where the minimum number of lines should be equal to the number of entry rows and columns shall be present. As you can see here, this time we nailed the exact amount of lines needed, thus we don't need to bother computing the unmarked cells in order to find the optimal solution, since we already achieved it. Finally, you will now go back to the original matrix table to take notes of the value of production that every operator machine pair did, bringing the results of maximum production efficiency of goods. This will help you use the potential of every operators and machines that can up your economical supplies. Last will be the unbalanced problem. In this case, we will use a time efficiency per job problem. Unbalanced problems from the world itself is where the numbers of rows and columns are not equal to each other, resulting to using a dummy row/column to obtain balance between the total activities and resources. It is used to complete the matrix and form a square, as it is stated in the criteria that balance of rows and columns should be needed in using the Hungarian method. Then all of the entries inside the dummy row/column will contain zeros as its elements. We will use the Hungarian method to solve the problem. As we all know, when using the Hungarian method, the minimization steps are being used. So in this case, the minimum rows value are automatically 0 because of the dummy. Thus, we go to the minimum value per columns, which is 9, 12, 11, and 0. After subtracting all of them, this will be the result. Now, we will use this optimal table to mark the lines to find the most optimal solution in this assignment problem. After marking all the lines, we can now see and do the pair of person per jobs to find the most efficient time in this assignment problem. Going back to the first table, this will be the result of the time, the total minutes of the jobs that is being done by each person. You also need to label the dummy one to prevent it from, the use of dummy and preventing the other dummies to enter the jobs. As we go throughout this video, we can conclude that in minimization, finding the optimal method to solve the minimum cost efficiency, which is the tasks, machineries, and etc., will also be the basis of optimal checking that is implemented in other problems. For the maximization, a way to know the maximized efficiency of production with the given elements for the assignment. This is also the time where the assignment problem is where you subtract the largest entry into the whole table, and we'll also use the minimization steps for the problem. As for the unbalance, if the problem is not a square matrix, it is called an unbalanced assignment problem. Dummy rows or columns are added to the matrix with 0 elements on it. And in the end, you will not use the one that is assigned to the dummy, as it is not efficient like the others. That's it. Thank you for listening and have a nice day. These are the references for my work.